this is the video for Lab 22, which is surface hydrologic analysis. So the first thing you're going to do is open up exercise 22, and then we're going to want to go to our working environment and set our current and scratch workspace as exercise 22, which should be the default. And then we can press OK. Now we want to extract the Laurel Creek Cherry Run watershed. So if we go back to map, go to select by attributes, input rows, we want watersheds and RCS, new selection type, where HU10 name, and then is equal to Laurel Creek dash Cherry River, or Cherry Run. Yeah. And then we can apply. And now we want to extract this into its own feature. So we can go right click on the watersheds, go to data, export features, and then we can rename this watersheds extract and press OK. Now we want to go extract the DEM for this layer, so we can go to analysis, tools, and we can look up extract, find mask under spatial analyst tools. We want our input roster to be the watersheds extract. Press OK. We want our input roster to be the elevation roster. Actually, so elevation, and we want our input roster or feature masks to be watersheds extract. And then we can rename this to DEM underscore extract. And we can run. Now we can clear our selection, and if we right click the DEM extract and we press zoom to layer, it'll zoom to our selection, or what we're going to be working with. Now we want to fill in this DEM, so we can go back to tools and we can search fill, and we want our surface roster to be the DEM extracted, and we can call this filled, and we can run. And now we want to create a flow direction grid, so we can go back to geoprocessing and look up flow direction tool. We want our input surface roster to be filled, and we want to call our output roster DIR. And we can run. this is the video for exercise 22, working with hydrolog. This is exercise 22, surface hydrologic analysis. First thing you're going to want to do is open up exercise 22, APRX file. And then we're going to want to create a selection for the Laurel Creek Cherry Run watershed. So we go to select by attributes. We want our input row to be watersheds NRCS. We want our field to be HU10 name. And we want this to be equal to Laurel Creek Cherry River. And we can apply. And then we can extract the selection to a new feature. So we go to right click on the watershed, data, export features, and we can rename this to watershed underscore extract, and okay. Now we want to extract the DEM, so we can go to analysis tools, and we want to go to extract by mask. Under spatial analyst tools, we want our input roster to be the elevation roster, and we want our feature or mass to be the watershed extract. And then we can rename this output roster to be DEM underscore extract, and we can run. Now we want to zoom into this layer, so we right click DEM extract and we click on zoom to layer. We can also clear our selection. And now we want to fill in this DEM. So if we go back to geoprocessing and we look up fill, we have our input surface roster as DEM extract. And we want to rename our output surface roster to filled. And we can run. Now we want to create a flow direction. So if we go up back to geoprocessing and we search flow direction, under spatial analysis tools, we want our input surface roster to be fill. And we want to name our output to DIR, and we can run. That should end up looking something like this. Now we can create a flow accumulation grid. So if we go back and we look up flow accumulation, we want our input roster to be DIR, and we want our output to be called ACC, and we want our output data type to be float, and we can run. Now we want to extract the streams. So if we go to roster calculator, under spatial analysis, we want our ACC to be less than what we calculated for question 10, which I got 899.3, and we can rename this to streams 1, and we can run. If we want, we can change the color of this to blue. And now we want to reclassify this. So if we go to our reclassify tool, under spatial analysis, We want our input roster to be streams 1. We want our read class field to be value. And we want our new values to be no data at the top, 1 in the middle, and then no data at the bottom. And we can call this streams 2, and we can run. And now we want to create a stream link tool. So we can go to stream link, spatial analysis. We want our input stream roster to be streams 2. We want our dir as our flow direction, and then we can rename this stream underscore link, and we can run. And now we want to change the symbology to unique values if it showed up in black and white. So we can right click, symbology, unique values. And we can close it. Now we want to extract the watersheds, so we can go back to our geoprocessing under tools, and we can look up watershed. And we want our flow direction as our dir, our input roster to be streams link, we want our pour point to be value, and we can rename this output to watersheds. And we can run. And now we also want to change this to unique values. So if we right click, symbology, change our primary symbology to the unique values. And then we change it to this color scheme. We can close. Now we want to convert our results to vector features. So we want to use the streams to feature. We want our input stream roster to be streams 2. And we want our flow direction to be dir. And we can rename this output to streams underscore lines. We want to check simplify polylines, which should be automatically done for you, and you can run. If not, just click on it. And we can change this to blue. And now we want to convert our watershed to a roster. So if we go back and we go to roster to polygon, or we want to convert our watershed roster to a polygon. So we want our input roster to be watersheds. Okay, we want our field to be value, and we can rename our output to watershed underscore poly. We do not want to simplify polygons, And we can run. And now, if you look at the attribute table for this, you can answer the question of how many unique watersheds were created. And then our next step is to calculate the stream order. So if we go back to tools and we look up stream order, we want our input stream roster to be streams 2. We want our flow direction roster set as dir, and we want our output roster to be called stream underscore order, and we want to use Strahler method of stream ordering, and we can run. And then the final step you guys will want to do is to create a map. So you want a title with your name, a north arrow, and a scale bar. The watershed boundaries as polygons are shown as hollow polygons. Stream lines as vector lines are shown. A hillshade is generated from the DEM and it's displayed beneath the watershed boundaries and streamlines. And a legend showing only the streamlines and watershed boundaries. And that is the end of exercise 22.